self.x and self.y. And that'll be used for collisions later on. So now what we need to do is we need to actually update our update method from entity. So what we can do is we can create create a update method in here, and we can just pass the screen and the delta time. And then what is going to happen here is we first are going to want to actually still call this update. So what we'll do is we'll do super.update. And we have to pass in the screen and the delta time. Now up here, we actually want to update the distance that they moved first. So what we'll do is we'll just do self.moveEnemy, and we have to pass in delta time. And that will be good for the enemy as of right now. We'll do collisions and stuff a little bit later, maybe inside of the main method. So what we're going to do is we're going to create a tower. So first we need to import those classes we just made. So we can import entity, we can from tower, import tower, from enemy, import enemy. Okay. So to create a tower, what we do is we do tower equals tower like this. And we actually have to pass in all of those parameters that we created. So the what we're going to want is the center of the screen. So screen center is going to be equal to 400, 400. Or no, sorry, it's 720, not 800 up here, so it'd be divided by 2. What we can do is we can do screen dot get size, or we can do get width divided by 2, and screen dot get height divided by 2, and that'll get the center of the screen. So then the tower position is going to be tower X. We don't want it to be in the direct center, this X here, because we're not putting the tower, like, we're not placing it by the center of the tower, we're placing it by the left side of the tower. So the tower left, I guess we could say, or just tower X, is going to be equal to this screen center of 1, because we want to get the, or 0, because we want to get the width one, minus the tower size. So we need tower size here, which is going to be maybe 720 divided. Okay, we can do 60. Does that make sense? We can try. Yeah, we can do 60, I suppose. Since 1 by 1, we only need one element in this. So we're going to do minus the tower size divided by 2. So that basically 1/2 is going to be the left of the center of the screen, and 1/2 will be on the right side of the center of the screen, which centers the object. Exact same thing for the Y. Exact same thing. We just have to change it to Y, and we have to change it to the second element. Okay, so now what we can do is we can pass in the position by doing tower X and tower Y inside of a tuple. We can pass in the tower size, and we can pass in the health, let's say 100, and then the image path is going to be, sorry, I guess I have to close this for a moment. I apologize, my Visual Studio Code is full screen right now. Okay, there. So yeah, if I drag it like this and we go back to this for a moment, what we'll see is we'll see that our script here, main is here. So we have to go inside of sprites, and then we can grab our sprite. So to do that, let's just do that real quick. We go, the path is equal to sprite slash tower1. Whatever you named your tower, and then the extension is PNG I used. I can check over here. Yep, so that's it. And that'll create the tower. Now what we want is we want enemies to spawn by waves, essentially. So that so what we'll do is we will do wave. So our wave that we're going to start as wave 1. And I think what I'll have is for each wave the number of enemies that spawn will be the number of wave that you're on. Okay? So what we want to do is we want to create a enemies list, which will hold our enemies. And then what we'll do is inside of our loop, actually out here, what we'll do is we'll do def spawn enemy. We'll create a method here. We want the distance away from the tower, and I believe that's all for right now. Actually, no. We'll want the speed and the damage. Okay. So what we're going to do is we're going to do the same type of math as before. So what we'll do is we'll do x is equal to math dot cosine. Oh wait, we have to get a direction as well. So the way to get to direction is we do direction is equal to, and we already imported random. So what we're going to do is we're going to do math dot, no, not math, it's just random dot, it's not random dot unique, it's random dot uniform, yeah. And this will get a floating number between 2 points, so between 0 and 2 pi. Now since this is a math class, I won't really explain how this works, but basically this is going between 0 and 360 degrees in a circle. Then what we'll do is we'll do our x is equal to that direction, the cosine of that direction, times the distance, and same with the y. It'll be the direction times the distance. So now that we have the x and the y, this needs to be displacement from the tower. So it's not, or from the center of the screen is what we'll do. So what we need to do is what we'll do is displacement x and displacement y. And what we'll do with that is we'll just say x is equal to screen center of 0 plus displacement x. So if it's negative x, it'll be moved to the left, and if it's positive x, it'll be moved to the right. And y is going to be the same thing. Oh, sorry. Screen center 1 plus displacement y. So that will get our position of the enemy. So what we can do is we can say return direction is equal to the direction plus math.pi. What this is doing is basically say like you have an angle of 90 degrees. The way to get the opposite direction is to add 180 to get the opposite direction. Adding math.pi, since a full circle is 2 pi, adding math.pi is like adding 180 degrees, which will allow us to get the opposite direction. Now what we can do is we can say that the enemy is equal to the enemy constructor of the position, which is going to be a tuple, the tuple of x and y. The size, which we'll make the size maybe a little bit smaller than the